Good day, everyone. I'm Wenbin, and today I will be walking you through our team cloud infrastructure solution. Our team consists of three members, which is Chang Kai Xiang, Tan Kai Sing, and Lan Wenbin. Our project tackles a critical issue faced by XYZ University. Their students' record application currently experience server slowness and downtime due during peak emission during due to extreme traffic spikes. This causes significant user impact as students cannot access their records and administrators face productivity loss during these critical windows. To solve this, our project goal was to transform their legacy architecture into a modern cloud-native proof of concept. Our design focused on four core requirements: high availability, which ensure there are zero single point of failure, and scalability, allowing the system to respond automatically to fluctuating user demand. And lastly, security, protecting sensitive student data and database credentials. And finally, the performance, maintaining fast response time even under heavy user load. Now, I'll talk about the architecture diagram. This architecture we deployed to meet the university needs. As you can see, the network foundation, the entire environment is hosted within a single AWS region using a virtual private virtual private cloud or VPC. To ensure high availability, we divide the infrastructure across two availability zones, with each zone containing both public and private subnet. When users access the portal, their requests hit on an elastic load balancer. This load balancer acts as a traffic distributor, evenly routing requests to have healthy server across both zones. Our application runs on EC2 instance governed by an Amazon EC2 auto-scaling group. This allowed the web tier to automatically expand or strike based on the actual traffic, ensuring consistent performance without provisioning. To protect sensitive record, the Amazon RDS database is deployed entirely inside a private subnet, completely isolate, isolate from direct internet access. Finally, to ensure maximum security at the application layer, our web server securely fetch the database credential directly from AWS Secret Manager, meaning no passwords are even hard-coded into our source code. Now I will talk about the cost estimation. I'm pleased to report that this high availability architecture requires 0 USD in upfront costs. The estimation monthly running cost is $61.50, bringing the total 12 months cost to $733.80. The monthly expenses are distributed effectively across our managed service, which include Elastic Load Balancing, Amazon EC2, Amazon RDS for MySQL, and Amazon VPC Public IPv4. For the elastic load balancing is our higher operational cost at $22.27 per month to manage traffic distribution. For the Amazon EC2, utilizing two T3.micro instance, which costs $16.46. For the Amazon RDS for MySQL, run at $14.71 per month using db.t3.micro instance. For Amazon VPC public IPv4 addresses account for $7.30. Finally, AWS Secret Manager secure our credential for just 41 cents as a month. This proved that we can deliver a scalable, enterprise-grade architecture for the university while maintaining the high cost-effective. Now I will pass it to Chiang Kai-xiang to talk about more.
Now that we have discussed the cost estimation, now let's dive into the core of our project, which is the implementation. So first, we established our network foundation using the Amazon VPC to ensure high availability. We partitioned our network into four subnets across two different availability zones. This ensures that even if one data center goes down, our student application remain online. And for security, we implemented a layer defense strategy. As you can see on the screen, our database security group is configured with a strict inbound rule. It only accepts traffic from our web security group on port 3306, and this can prevent any direct external access to our data. We also configure specific route table to manage traffic flow and utilize the IAM instance profile. By using the lab instance profile, we ensure our EC2 instance have the necessary permission to communicate with other AWS service without hard-coding the credential. And moving on to the compute layer, we have our EC2 instance running across multiple zones. Our target group monitors the health of this instance. You will notice in a slide that the load balancer auto detect the health of each state, ensuring users are never routed to be a failing server. And to handle the traffic spike mentioned in our introduction, we configure an auto-scaling group which set a limit of 2 to 4 instances. This allows the system to breathe, expanding during peak emission period and shrinking when traffic is low to save costs. And for our data layer, we choose Amazon Aurora MySQL, and we enable automated backup with a 7 days retention period for high availability. If a disaster occurs, we can restore the database to any point within that window. And security was further tightened by disabling public access to the database. Additionally, the cost-effective to be cost-effective, we utilize Aurora Serverless version 2. This scale capacity in real time based on application demand, ensuring we only pay for what we use. And to prove the high performance requirement, we use Amazon Cloud9 to run the stress test. We push the system to its limit, successfully processing over 297,000 requests at a rate of 991 requests per second. And the architecture held firm under heavy load. And finally, for credential security, we integrated AWS Secret Manager. Instead of storing database password in a code, the application fetch them securely at runtime using the secret IAM you see here. And next is the web functional demo here, which we will demonstrate later. Yeah. So we can add a new student here through the form and also editing existing record as well as deleting it. So, in conclusion, we have successfully deployed a resilient cloud-native proof of concept for XYZ University, and we met every requirement here, such as the functional CRUD operation, scalable and load balance compute, secure private networking, and high performance validated by stress testing, and also the cost optimizer using the leverage T3 micro instance and Aurora serverless v2. So this journey wasn't one of the challenges that we have overcome here is by uh, debugging the RDS access. We initially faced connectivity issue which we resolved by auditing our security group rules, and we also learned that the importance of collaboration, streamlining our tasks to avoid deployment conflict in the shared VPC. And so by looking ahead, we have a clearer roadmap for the any future improvements such as enhanced security by implementing HTTPS via AWS Certified Manager, and also higher redundancy, upgrading to a full multi-asset RDS cluster, as well as optimization using Amazon CloudFront to reduce latency for students accessing the portal from different regions. And this project has given us the hands-on skill needed to architect secure, scalable solution in the AWS cloud. And that's all from here. So first of all is adding the new student function. As you can see, the student is successfully added, and now I'm going to try to edit it. We'll try to edit the address. And it is successfully edited here in the address. And the last function is to delete the student. Okay. And is successfully deleted.